So now we're going to look at how to make a stem and leaf plot and a dot plot. So I have the following example. A random sample of 20 police districts in a certain region was taken, and the average number of drug-related arrests per week were recorded as follows. And we have 20 different districts that have their average number of drug arrests recorded there. Okay, so we want to make a dot plot, and then we'll make a stem leaf plot. So let's start with the dot plot. Notice that I have made a scale, and because again I'm drawing on the screen, it's not perfect. All of these tick marks should be the same length, and they should all be the same distance apart. And of course, trying to draw on here is not perfect with my stylus. Okay, but notice that I have started with the smallest value, and I did go and put these in order because it's going to make this easier to do, both for the dot plot and for the stem leaf plot. You don't have to put them in order, but it is easy to see all your data that way when you get ready to do these plots. All right, now to do a dot plot, I started with the 29, which is the smallest piece, and I've made sure that my scale goes all the way up to the 60, which is the last one. And what we're going to do is put a dot above each number on the scale for each of the pieces of data here. So I'm going to draw directly on this scale that I've got here. My first number is a 29, so directly above the 29, I am going to place a dot. And then notice I have two 31s. So here's 30. 31 will be right there. And at approximately the same height, I want to place a dot. And then above it, about the same distance away that I put it from the axis, I want to put a second dot because there's two of them there. There's 132, so 32 will be right here. Again, same height, a dot. 33, there's three of them. So here's 33. I'm going to make a dot. And then at approximately the same height as I made the second dot for 31, I want to put another dot. And then again, keeping it consistent in distance between dots, I'm going to put the third dot for the third 33. All right, 34 only has one dot. And that wasn't very perfect. 35 only has one dot. 36 has nothing, so I won't put a dot there. 37 has one dot. 38 has one dot. 39 has two, so we'll put one dot and approximately the same distance up above it. I'll put another dot. 40 has one dot. 41 has one dot. 42 has three dots. So three 42s. 43 has one dot. And now, way over at 60, which is right here, we have a single dot. Now notice that the dot plot is similar in a way to our histogram. It has peaks. So notice we have a peak right here, we have a peak right here, and we could think of this as a bimodal distribution. And this piece of data that's far away from the others is what we call an outlier. It's a long way away from all of the other data. Now that could mean that something strange is going on in this particular district, or it could be an error in the recording of the data. So we have to keep that in mind. Outliers have a tendency to pull the average of the data off. So keep that in mind. We'll talk about that later when we get to doing calculations of what we call the mean or the average of the data. However, the nice thing about a dot plot is, unlike a histogram, we can get the data back from the dot plot. Notice that right here, I can notice, okay, this is at 33, and there are three dots at 33, so I know that there were three 33s in the original data. The disadvantage of a dot plot is if there's a huge spread here. These dots just sort of run together and it becomes very difficult to tell what's going on with the data. So we can use a dot plot if the data is fairly close together, if it's not too huge of a range. Now, that's how we use a dot plot. Let's now look at a stem leaf plot for this data. And I'm going to go down to the bottom of the page. I have set up a table. We don't necessarily have to have a table for a stem leaf. We can just draw a line between what we call the stems and the leaves. Since our data is consisting of 2-digit numbers, my stem is going to be 1 digit and my leaves on the right-hand side are going to be 1 digit. Our leaves will always be 1 digit, but our stems might change. If we have 3-digit numbers, we're going to have a 2-digit stem and a 1-digit leaf. If we have 4-digit numbers, we'll have a 3-digit stem and a 1-digit leaf. So notice that the leaves will always be 1 digit and the stems will consist of the remaining digits. We get our stems from the numbers themselves. Notice that I started with a 2, and that is the first digit of our 29. And then we have 3, 4, going all the way up to whatever the first digit is of our last number. Our last number had a first digit of 6. So I have a 6 here. Oh, and let me get out of this draw thing here. Okay, so now what we do is we go through our numbers, and the leaves are the second digit. So we had a 29. So over here, we put a 9. We had 2 31s, so I'm going to put the second digits only, so a 1 and a 1. And I'm putting a space in just to keep them nicely spaced out. Now notice, I also have a 32, so I'm going to put a 2 for that second digit. I have 3 33s, so second digit 3 times, 3, 3. I have a 34. So a 4, a 35, a 37, so I want the 7 only, a 38, so I want the 8, a 39, so 2 9s. All right, now we go to 40. First digit's a 4, so I want the 0 for that second digit. I have a 41, so I want a 1 for that second digit. I have 3 42s, so I need to do the 2 3 times. I have 1 43. I have no numbers in the 50s, so the 50 stays blank, which gives us a gap again between our data that we have on the low end and that 60 that sort of stuck out on the dot plot. Now 60, I need to put a 0 there to represent the right-hand digit. All right, so this is our dot plot. Now notice it too is like a histogram. If we turn it on its side, we can see that the majority of entries are 30-some and 40-some. It tells us where the peak of that histogram would be. We can also get our data back again if we need to get it back from the plot that we've made. Now, unlike the dot plot, the problem with a stem and leaf diagram is it becomes extremely huge and cumbersome if there's too much data. So with small numbers of data, like these 20 pieces of data that we had, a stem and leaf is a good way to plot the data and make it look like a histogram would look. We can do it even without making our frequency histogram or frequency table before we do the histogram, because this sort of covers it. But with large numbers of data, this is not a very good graph.